line Swift. Okay, so you ready? Let's start with more. So I'm looking at 2 lines of Swift here. What do you think this is trying to do? So there is a little starts with well, first of all, let's just run it and see what happens. So I'm just going to copy this in the terminal, put it in the interpreter, and we get with this results 10 and some other line after that. So what has happened is it seems like we're getting the result of 2 plus and then 1 times 8. So it's 2 plus 8 and we get 10. That's what's happening. And then we get that result, which is 10, printed on the screen. So if you just want to look at the different parts of this this expression, there is that keyword let. So that let is for defining what's called a variable. So this is declaring something. So let is saying I want to define something, declare something. And then I have that name A here. A happens to be just a name. It's what is called a variable. So you're saying I'm going to define a variable here. And then on the right side, you give it the value for the variable. In this case, is some numerical expression. And then at the bottom, on the next line, you're saying print, and then inside inside a parentheses, it says A, which is the variable we just defined. So it seems like what we're doing is defining A to be the value that's computed by 2 plus 1 times 8, which is 10. And then printing it on the screen, and that's what's exactly happening here, and you get that 10 as a result. So what is that colon and int all about? Well, this is what is called a type declaration, and this is when you tell the language what's the nature of this variable that you're defining. Int is actually short for integer, which is another name for saying a whole number. So we're saying, hey, Swift, this variable that I'd like to define happens to be of type a number or integer, and so it knows how to deal with it. What kind of operation can it work with it or not? Okay, so does that make sense? So this piece of code, what it's doing is defining a number, and we're going to give it a name called A. And it's going to give it a value that's evaluated by evaluating this expression 1 times 8 and then adding it to 2, and then it's going to print it to the screen. So far so good? Okay, now let's go to the next one. How is this one different? Okay, looks like it's the let we recognized before. Let is just defining that, saying I'm defining. We're giving it a different name. We can't use the same name because this interpreter here that I'm running in the terminal has history, basically. So if I just type in A here, it recognizes it. And if I print A again, it prints the value for A here. So basically saying A is already defined. So if I want to define something, I better give it a new name. Now, what does this do? It has that extra parentheses around 1 and 8. Now, what do you think that does? Well, as you remember from math, this is basically giving you precedence or preference which expressions should be computed or evaluated, in this case, first. So you're saying make sure you multiply 1 by 8 before you add it to 2. As we seen before, we still get the same value 10. So this tells us that it's actually by default it's right associative here. So the one when we didn't have the parentheses, it still did the same thing. It did 1 times 8 and then it added to 2. Does that make sense? Okay, so you use parentheses to ensure precedence in the numeric expressions, and then we print it as before. Okay, the type was the same, still was int, which is a number. Now let's go to the next one. Now how is this one different? Well, this one is putting the parentheses around 2 plus 1. So clearly we're saying add 2 to 1 first and then multiply it by 8. So this one has a different value, right? It will be 2 plus 1, which is 3, times 8, which is 24, and sure enough you get 24. Now I didn't say we always get this extra line after it prints like we told it to. We get this extra information. This is just interpreter saying I recognize what you just used, and it gives it the type that it has, it knows associated with, which is int, and the value that it just it has currently. So this is just extra information. This last line that you see here, c colon int equals 24. Okay, so that's just the interpreter saying I recognize the value of the c. But what we told it to do is the previous line, which is printing the value on the screen. So it printed 24 as you see here. Okay, moving along. Now this one is different. How is it different? Okay, so we're using star, which is for mathematical times operation, so just multiplying it together. Now it's funny because we're using a and b. Now is that okay? Yes, it's fine because we have already in the previous lines that we run here have defined a and have defined b. They both have the value 10, so we can just say a times b, and d can be equal assigned to that. So if I just run this expression, you get 100 because a was 10 and b was 10, and it says d is now 100. And the type associated with it is still integer, correct? It's a number. That makes sense? Okay, now let's move on. Now, how is this one different than the previous one? Is this okay? It seems like it's missing that type declaration, the colon integer. Well, let's try it. Let's see if it's okay with that. It's happy with that. Yeah, it pasted it there, and it still got 100 for D1 this time. So what's happened is that seems like that type declaration for D was optional. Seems like you can just leave it out. Now, this is what is called type inference, and some languages allow you to do that. So, and the way it works is that it says, okay, yeah, you defined a before, and I already know that that's an integer, and b before, I know it's an integer. So you multiply those together, it kind of figures out, okay, so the result should be an integer itself. So it kind of figures out, oh, okay, d1 is itself an integer here, as you see. You didn't have to tell it that, so it kind of infers that. Okay, so keep in mind, type declaration is sometimes optional, but not always. Sometimes required, as you see later. Okay, you're ready to move on? Okay, now the next one is a difference. So we're defining a variable called e. So far so good, but the type is something we haven't seen before. Well, this type is called string, because if we just work with numbers in a program, we just have a calculator. It kind of gets boring. So yeah, in a program you want to deal with what is called strings, and these are strings of characters that make up a whole sentence, and the value that we're giving to e in this case is name Joe. And you have the string value by using the double quotes, open and close double quotes, and then inside it you have characters or names or numbers, etc. So this is just defining a type which is called string. A variable name for is e, and we're assigning the value Joe to it. So we can just go ahead and print it, and it prints Joe, sure enough. Okay, so far we've seen two kind of types. Which are those types? Yes, so we've seen integer before, int is the short in Swift, and strings. So two types of values. Okay, now what is this next one is trying to do? What do you think? So we already defined e, and e was the value Joe, and now F is also a string, and we're assigning a value E plus a string which is space followed by do to it. Now, what do you think this is trying to do? That's right. So clearly this plus isn't your arithmetic plus. It concatenates two strings together. So E is a variable which was already a string and had a value Joe, and we're going to concatenate that to this string. So as a result, sure enough, if I run this, you get value of F will be Joe followed by Do. So I have a little space just so designate the first name and last name, separate them together. That makes sense. So you notice this plus, which is called overloaded, because it does a different thing depending if you're adding numbers together or you're adding strings together. So plus in this case isn't adding, is concatenating, putting together two strings. So the context where an operation is evaluated is important. Does that make sense? So in this case, plus just takes a string on its left and a string on its right and adds them together. In this case, we're assigning it to a variable called F. That makes sense? Okay. Something that I didn't mention is that the variable names need to start with a letter, but they can have more letters or numbers after them. So for example, I could just say name instead of F, right? Or I can say name 1, 2, 3. That's fine too. What is not allowed is just calling a variable with a number. So that's not allowed. You have to start with a letter. Okay? So it's convention that we start with a lowercase, by the way. It's called camel case. Lettering, naming, when you name a variable. If it has more than one variable, it's convention that you capitalize the words after the first one, not the first word, but let's say name of friend, then I just capitalize of and friend like this. So this is just convention in many languages how to name your variables. And it's always good to use descriptive name variables, so you know if somebody else is reading your code, you just don't see A, B, C, D, because they're meaningless. You use something that's actually gives some information to make it more readable. Okay? Very well. Now let's move on. Now the next line is doing something different. So what is G is being assigned and we're not giving it type, maybe that's fine, but D plus E. So if you go ahead and I don't remember D and E, so let's just print them and find out what they are. So D is 100, and if I print E is Joe. Okay, so that's funny. So here we're saying G equals D plus E. What do you think should happen here if I do that? Yeah, that is, in fact, is going to be an error, because here you get an error saying binary operator plus cannot be operands of type int and string. So what it's complaining about is an error which is called a type error, and a programming language like Swift and Java and others, they do, as they compile your code, something called type checking. So type checking is making sure you're running operations that are compatible with the values that you have that's applied to them. So in this case, it's saying, oh, D, the variable D, is a number, an integer, as I defined before, and E is a string. You cannot add a number to a string this way. So that's why the types are incompatible, and therefore this operation is a type error. And the type checking process catches that and tells you that there is an error in your program before it goes ahead and runs it. Okay, so this is an error. We've just written our first bug. Congratulations. Well, actually, real bugs that occur in the real world are the kind of errors that the type checkers don't catch that because they're not so obvious. Otherwise, we won't call them a bug, because before you ship your program, your software, you already get the error, so you can go ahead and fix them in this case. So it's good to get type errors, because then you can fix them before you run your program, in a way. Okay, now, so was that clear? This operation wasn't good because we're adding a string to a number and those are compatible, and we got a type error. And we are never able to get to that second line print G, because that top line threw an error and the program compilation stopped right there, and we never run the program after that. Okay.